Assalamualaikum and hi, my name is Amirul Haziq bin Zainudin, metric ID MA18122 from Section 6 and Group 6. Today our group will present about the experimentally long report, which is determination of friction losses in pipes. In order to pass the engineering fluid mechanics lab, our group had to perform pipe friction losses determination. The head loss in pipelines tested in this experiment to access major and minor losses in different piping systems. The head loss is a measurement of the fluid's gross head loss as it flows into a conduit. Friction loss is the head loss along the pipe surface. Owing to the roughness of the pipe wall, fluid movement in the pipe encounters frictional resistance, which result in local currents within the fluid. The shear load of the flow is often affected by whether it is turbulent or laminar. The decrease is determined by the form of turbulent flow surface, while the roughness of the wall has little impact in laminar flow. In fully turbulent flow, the turbulent flow is determined by the Reynolds number and the relative roughness of the rotor wall. This assumes that the head loss of a pipe can be calculated using the Darcy-Weisbach friction factor, pipe length, pipe diameter, and fluid flow rate in the pipe. Introduction. The number of major and minor energy losses in a pipe structure is the overall energy loss. Owing to the viscous properties of the fluid and the roughness of the tube wall, significant losses can arise. As the strain works to penetrate the frictional resistance, major losses allow the pipe to collapse. Pipes are commonly assumed to operate fully and circularly in hydraulics. Resistance to friction affects the flow of liquids through vessels, resulting in a lack of head or liquid energy. In this experiment, you can test fluid flow in a pipe network and investigate a variety of fluid flow rate calculation methods. On a pipe pressure descent, the effects of skin tension, tubing network setup, and the tube contacts will be investigated. The type of fluid viscosity affects the head loss in this experiment. The Darcy-Weisbach equation is used to calculate the head loss due to friction in pipes during this experiment. This is the Darcy-Weisbach formula, where the HF is the head loss due to friction, L is the length of pipe, D is the diameter of the pipe, V is mean velocity of flow in the pipe, and F is the Darcy-Weisbach friction factor. Minor losses in pipe flow arise due to fittings, pumps, progressive and abrupt expansion or contraction, as well as admissions and departure effects in addition to skin friction losses. In certain cases, losses are calculated experimentally and compared with pipeline flow parameters. The loss factor of coefficient of K is used to characterize the friction losses caused by the fittings. Problem statement of this project is there will be a number of issues that will arise over the course of this experiment. We need to figure out how much the big losses are worth. If we don't, we won't be able to go on to the next level. The head loss in a length of tubing is measured as a result of discharge in this experiment. Pressure sensors will be used to measure head loss in small diameter plastic tubing. The value of Darcy-Weisbach must then be determined using the formula above just now. Finally, there are friction losses. Objectives of this project are to determine and examine the volume of velocity for various types of pipe of various diameters and to determine the pipe's major, minor and friction losses, as well as the total fluid flow calculation methodology. Scopes of this project: to determine whether a laminar or turbulent flow will exist during the experiment and to investigate the effects of various pipe diameters on velocity. The friction effect will be linked to the spectrum of flow speeds.
Hi everyone, I am Chandra from Group 6. Today I would like to present on Chapter 2 and 3, Lab 3, Friction Flow in Pipes. Let's see the theory. During a flow distribution section, friction is directly related to the pressure drop and head loss. The pressure drop is then important in determining the pumping power requirement in order to make sure the system goes well. Friction along the pipe walls and turbulence due to changes in streamlines through fittings and appurtenance cause the head loss. Various joining components such as fittings, valves, bands, elbows, teeth are involved in a typical piping system. Loss coefficient is usually used in minor loss expression as shown in the slide, where HL is additional irreversible head loss in the piping system due to the insertion of the components. In straight pipe, there are two types of flow, that is laminar flow at low velocities and turbulent flow at high velocities. Laminar flow characterized by smooth streamlines and high ordered motion, whereas turbulent flow is characterized by velocity fluctuation and highly disordered motion. As you can see, the Reynolds number can be found in the equation shown. Now let's move to the apparatus used for this experiment. First is fluid friction apparatus, hydraulic bench, pressure sensor, data measurement and data equation. Moving on to the procedures, there are totally 8 procedures for this experiment. First is opening all the valves to ensure the flow of water. The pump is turned on to flow the water across the pipeline. The third is the control valve is adjusted to adjust the volume flow, and also to begin experiment unused valves are closed. The step 5 is pressure sensors are added to the valve to measure and record readings of pressure 1 and 2. The sixth step is flow rate indicator is present, which shows the result in LPM unit. And then we repeat the above procedures for few flow rates and also on another pipe for second experiment. That's all from me. I will let my group member to continue. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hasbullah bin Bakar and my ID is MA18126. So today I'm going to continue present about the result, graph and discussion. So today it consists four type of experiment that we have gone through, which is first one is the straight pipe. So as you can see, the data for the straight pipe, also the two graphs that have been provided. So from the graph, we can see that when the velocity increase, the head loss calculated and the measure value for the straight pipe increase because the volume flow rate is increased. However, the friction coefficient for the calculated and the measure value are remain same over the time when the volume flow rate increase and the Reynolds number increase. However, from the data of measured and calculated values from the head loss, the measured values are lower than calculated values, which is abnormal since some values are distributed by some errors, including due to the lack of maintenance and calibration on the apparatus. Thus, the increasing of the velocity will decrease the value of the coefficient as well will increase the value of the head loss. Next, we go for the elbow 90 degree. So as you can see from the data and also from the graph, so we can see that when velocity increase, the head loss calculated and measured for the elbow 90 degrees increase because of the flow rate increase. However, the friction coefficient for calculated and measured value remain same over time when the volume flow rate increase and Reynolds number increase. From data of measured and calculated values for head loss, the measured values are lower than calculated values, also same, which is abnormal since some of value are distributed by some errors. So this is because the maintenance and calibration of the apparatus. Thus, the increasing of velocity will decrease. The value friction coefficient as well will increase the value of head loss. We go for the bend pipe 90 degree. So as you can see in the data and also from the graph, uh, we can see that when velocity increase, the head loss calculated and measured value for bend 90 degrees, bend pipe 90 degrees increase because of the volume flow rate increase. However, the friction coefficient for calculated and measured value are remain same over time when the volume flow rate increase and Reynolds number increase. However, from the data measured and calculated values for head loss, the measured values are lower than calculated values, which is abnormal since some values are distributed by errors also. Thus, the increasing of velocity will decrease the value of friction coefficient as well, will increase the value of head loss. Let's we go for the pipe 45 degree. So from the data that we produce and also the graph, we can see that when velocity increase, the head loss also calculated increase, while measured value remains same for the bend 45 degree because of the volume flow increase. However, the friction coefficient for calculated and measured values are remain same over time. From the data of measured and calculated values for head loss, the measured values are lower than calculated values, which is abnormal since some of value distribute by errors also. So the conclusion that we can make is then we finally reach our lab objective by determining some of the parameters such as head loss by pipe friction coefficient, loss velocity, Reynolds number, which is clarified by the dynamics of fluid phenomena in pipes. Then we look at the parameter and explain how they apply to the pipe losses. As a result, for all types of piping systems, the velocity and Reynolds number are increased as the volume flow rate increase. However, as the volume flow rates increase, the friction coefficient decrease. It also be noted that we discover discrepancy between the measured and calculated data due to the calibration of the apparatus. That's all from me. Thank you.